We are covering average rate of change here today, so take notes. All right, so we have 2.4 average rate of change. So if you remember in previous sections, we covered net change of a function from like A to B. And so we're going to expand on that idea here. So let's just kind of recall. Net change of a function f from A to B. And the formula for that is f of b minus f of a. And remember here that the order does matter. If it's asking you for the net change from A to B, make sure you do f of b first, since subtraction is not commutative. Okay, so that was previous section. So now what we're going to look at is average rate of change. And part of the formula for this is this formula here for net change. So average rate of change. So here, if they're asking for the average rate of change of a function from A to B, then what happens is they're asking you to find this, f of b minus f of a. Okay, so that's net change. But here, since we're talking about a rate of change, then here we're going to look at that change that happens over, usually it's like over some time period or something like that. Okay, so over b minus a. Okay, so you might recognize this here as the slope. Okay, the slope of the line between these 2 points. So the slope of the line between 2 points. Okay, so this average rate of change, you can think of it like, okay, so for a line, the slope would be the same between any 2 points that you choose, right? And so if you were trying to, if a line was representing, like, let's say how fast you were going at a certain time, uh, the slope there, the slope of this average rate of change would describe how fast you were going at any given time. Well, if you have a line, then, that would be the same the whole time. But we know that, okay, if you're driving, a line does not really reflect how you're actually driving, right? So you might be going really, really fast, and then you slow down your speed, and then you come to a stop, and maybe you're stopped for a while, and then you start to accelerate, and then you go faster, 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 and then maybe you hold that speed for a while, and then you start to slow down as you come to the next stoplight. So your speed is always changing. So when you're trying to find your average rate of change or your average speed, then, you have to look at, oh, well, we can't look at it really from like a line where it's always the same, right? And so this average rate of change, you would look at your average speed uh, between, like, say, 2 and 3 seconds, or then you might look at your average speed between 8 and 10 seconds. So as you go along. Okay. All right, so let's take a look at a visual of this. What does this look like on a graph? So here, we know what slope looks like in terms of a line, but if we have some sort of different curve, okay, so let's suppose that we have a curve that looks like this. Okay, and so let's suppose that we have a point here at this x value, we'll call it A. And we have this other point on this curve at some x value, I'll call it B, right? And these x values, A and B, both have y values. So A has this y value, I'll call it f of A. And this B has a y value as well, we'll call it f of B. Okay, and so what happens is this formula, we're looking at the difference between the y values, and the difference between the y values is just f of B minus f of A, the difference of the y values, y2 minus y1, right, over the difference of the x values. That's x2 minus x1. Okay, so we can see here how this is very the same as your slope formula here. And you may have learned slope as, average rate of change. If you were in my class last semester, that's what we called slope. Okay. So let's take a look at this example. Suppose I have this function, f of x, which is equal to x minus 3 quantity squared. Oops, sorry. And suppose they're asking you to find the net change. That's what we learned before in previous sections. Okay, so find the net change and the average rate of change. So this is what we're learning today. Average rate of change between the following points. Okay, all right, so let's do this one. I'll do this one with you guys, x equals 1 and x equals 3. And then I'll have you guys do this one. B, which will be between x equals 4 and x equals 7. Okay? Okay, so we need to find the net change. So let's go ahead and do that here. We'll do the net change first. So again, this is the one that you guys learned before. So net change is just f of B minus f of A. So this is going to be f of 3 minus f of 1. So we're going to take this 3 and we're going to plug it in for x. So it's going to be 3 minus 3 squared. And then this subtraction here. And then this f of 1 means to replace this x here with 1. So it's going to be 1 minus 3 quantity squared. Okay, so here we get 0 squared minus negative 2 squared. And we get 0 minus, this is going to be 4. So we get negative 4. Okay, so we get -4, which means that it's decreasing. Okay. Now let's go ahead and do the average rate of change. And remember, this one is our slope formula, f of b minus f of a all over b minus a. Okay? All right, so f of b minus f of a, we just found that up above. Okay, so that is f of 3 minus f of 1 over 3 minus 1. Okay, f of 3 minus f of 1 is right up here. F of 3 minus f of 1, we already worked that out. It's -4. So I'm just going to go ahead and write -4 up here. And then 3 minus 1 is 2. And so we get -2. Okay. Okay, so let's go ahead and have you guys try letter B. Okay, so go ahead and give this one a try. Find the net change and find the average rate of change and hit the pause button. Come back and see if you get the same answer. Okay, so here, net change. F of 7 minus f of 4. So we're going to get 7 minus 3. 7 minus 3 squared minus 4 minus 3 squared. So that is going to be 4 squared minus 1 squared. That's 16 minus 1. So we get 17. Oops. 16 minus 1 is 15. Okay. 16 minus 1 is 15. Okay, so average rate of change. Let's do that one. Average rate of change. Okay, so here we are going to do f of 7 minus f of 4 all over 7 minus 4. F of 7 minus f of 4 is our net change, so it's 15. 7 minus 4 is 3. So we get 5. Okay. All right, excellent. So notice here that we are using the same function, but here we get a net change of negative, and here we get a net change of positive. And over here, we get an average rate of change that's negative and an average rate of change that is positive. Okay, so so this, when you're getting these negative results here, that means that it's decreasing. And over here, when you're getting these positive results, that means it's increasing. And so when you look at the function that we're dealing with, x minus 3 squared, that's a parabola, right? So that's a parabola that is shifted 3 units to the right, and so it looks like this. 1, 2, 3, a point there, there, and there. And so you can see that, yes, it is decreasing over here and it's increasing over here. And so that's why between 1 and 3, okay, so between 1 and 3, you have those negative results. And then between 4 and 7, you have those positive results. Okay. Okay, let's take a look at another example. This is more of an application problem. Just because there are more words, don't be afraid of it. It's still the same idea, average rate of change. f of b minus f of a over b minus a. All right, so let's copy this down. If an object is dropped from a high cliff or a tall building. Okay, so an object is dropped from a high cliff or a tall building. Okay, then the distance it has fallen. So imagine dropping this object and then it starts falling, right? Then the distance it has fallen after t seconds. So imagine you drop something off a cliff or a tall building, and this object starts falling. After like 2 seconds, it's fallen a certain distance. After another 5 seconds, it's fallen a certain distance, etc., etc. Okay, so the distance it has fallen after t seconds is given by the function d of t equals 16t squared. Okay, which is pretty cool that we have a mathematical function here that describes this behavior, right? So here is an object that's falling down from a building or a cliff, whatever it is, and the distance that it has fallen, the distance that it has traveled after a certain amount of time, is modeled by this one function that's right over here. Okay. All right, so let's go ahead and find the average speed. Find the average speed, which is the average rate of change. So let's write that down. Average rate of change. So average rate of change is just the general term or phrase that we use when we don't have when we don't have specific units or a particular situation that we're talking about. But average rate of change. Okay, so here, since we have this situation of this object being dropped, now we have some context. So we don't have to be general and say, find the average rate of change. We can be a little more specific with our language and say, find the average speed. Okay. So find the average speed over the following intervals. Okay. All right. So here, let's find that average rate of change or that average speed between 1 second and 5 seconds. Okay. So let's go ahead and find that average rate of change, average speed. So what we need to do is find f of 5 minus f of 1 all over 5 minus 1. Okay, so here is our function right up here. So that's where we're going to plug the 5 and the 1 into, okay? All right, so 16, 5 squared minus 16, 1 squared, all over 5 minus 1, which is 4. Okay, so that's 16 times 25 minus 16 times 1, which is 16, all over 4. If you don't have a calculator with you, or you're like, I don't feel like getting my calculator out and turning my phone sideways and whatnot, you can do little things like factor out that 16 and do 25 minus 1. But if you want to just use the calculator, that's fine. Okay, and then cancel this out. I don't feel like pulling out my calculator, so I'm not going to. And then 4 times 25 minus 4 is 24. And so then here we get 96. Okay, so what this is saying is that the average speed here is 96 feet per second. That's how fast it's falling. 96 feet per second. That's pretty fast. Okay, go ahead and let's see if you can do this one. This one is a little more abstract because this one, I'm not going to give you numbers, but I'm just going to give you some variables. See if you can do it. If you're completely lost, then just follow along. Don't hit the pause button. Okay, but if you want to try this, it's a little more challenging. See if you can get it, then hit the pause button. Okay, so for this one, let's find the average average speed between t equals a and t equals a plus h. Okay, so it's like this here is your b, and this here is your a, which is a, right? Okay, so go ahead and see if you can find that. If you're like, I still don't get it, here, try finding this. F of a plus h minus f of a all over a plus h minus a. Okay, so that's just your f of b minus f of a all over b minus a. Okay, go ahead and give that a try. If you're completely lost, just follow along. Okay, so here we're plugging into our function. So 16 times a plus h quantity squared minus 16 times a squared all over a plus h minus a. Okay. And then here we get 16 times square of a binomial. So that's going to be a squared plus 2ah plus h squared minus 16a squared all over. Over here, the a's will cancel out. So I'm left with h. I'm going to go ahead and distribute this 16 over here to everything inside the parentheses. So 16 times a squared is 16a squared. 16 times 2 is 32ah. And then 16 times 1 is 16h squared. And then I'll bring this one down, minus 16a squared. Okay, so all I did was bring this down here. Okay, so this cancels. I'm left with 32AH plus 16H squared all over H. I notice that the numerator, these two terms, both have an H in common, so I'm going to factor out an H. And I'll have 32A plus 16H all over H. And then I can cancel those. And so my final answer will be 32A plus 16H. Okay. So if you didn't quite get that, like I said, it's a little abstract with just letters and no numbers. But the more you do these, the more you get used to it. This here is known as the difference quotient. Known as difference quotient. And we use this in calculus at the very beginning. And what happens is this is leading to the instantaneous rate of change. So here, this average rate of change looks at, okay, well, how fast are we going between 2 and 3 seconds? How fast are we going between 7 and 9 seconds, right? Over a given period of time. And what this does, this difference quotient is leading to is what we call the instantaneous rate of change, not the average rate of change, but the instantaneous rate of change, which means instead of asking the question, how fast is that object falling between 2 and 3 seconds? What the instantaneous rate of change does is it asks, and we're able to answer the question, how fast is it going at 5 seconds? At exactly 5 seconds, how fast is it going? Instead of saying, how fast is it going between 4 and 5 seconds? Okay. All right, let's take a look at one more example with temperature. Okay, so let's suppose that we have this table of values that represents the temperatures at certain times of the days, certain times of the day. Okay, so here's the time, and here's the temperature. And the temperature is in degrees Fahrenheit. Okay, so let's suppose that at 8 a.m., we start off kind of cool at 38 degrees. 9 a.m., we're now warming up a little, and I don't want to write all of the temperatures for every hour. I'll just write the ones for the hours that we're going to deal with. Okay, so 8 a.m., 38, 9 a.m., 40, we're warming up. And then by 1 o'clock, 1 p.m., okay, by 1 p.m., we're at 62 degrees. And then 3 p.m., we are at 67 degrees. And then at 4 p.m., we are cooling down, 64. And then finally, here around 7 p.m., we are at 51 degrees. Okay. And there are more, but let's just use these. Okay. Let's find the average rate of change. Average rate of change of temperature between the following times. Okay, so let's do these 3 times. Let's do between 8 a.m. and 9 a.m. Let's do 1 p.m. and 3 p.m. And go ahead and find it between 4 p.m. and 7 p.m. Okay? All right. Why don't you go ahead and try these 3? Okay, go ahead and try these 3. See if you can figure it out. You'll notice here in this example, we don't have a function, which is fine because we do have the table. And remember, these are your x's and these are your f of x's. Okay. All right, so go ahead and give that a try. See if you can find the average change in temperature. Okay, so I'm going to go ahead and do letter A over here. Okay, between 8 a.m. and 9 a.m. So that's asking you to find f of 9 minus f of 8 over 8 after 9 minus 8. Okay, so here when we look at f of 9, so I said these are your f of x values. So f of 9 is 40. F of 8 is 38. So 40 minus 38. 40 minus 38 over 9 minus 8, which is 1. Okay, so we end up with 2. 2 over 1, which is 2. So this means that we are changing 2 degrees Fahrenheit per hour. Okay, for letter B, 1 p.m. to 3 p.m. So that's f of 3 minus f of 1 over 3 minus 1. F of 3 is 67. F, which is over here. So here's 3 p.m. Its y value is 67. Here's 1 p.m. Its y value is 62. So remember, it's like slope. So it's y minus y over x minus x. 3 minus 1 is 2. So we get 5 over 2, which is 2.5. So 2.5 degrees Fahrenheit per hour. Okay, and letter C here, 4 p.m. to 7 p.m. That's asking you to find f of 7 minus f of 4 over 7 minus 4. F of 7 is 51. F of 4 is 64. 7 minus 4 is 3. So here we get negative 13 over 3. And so we get negative 4.3 degrees Fahrenheit per hour. And this one is negative, which means that the temperature is decreasing over this time period. From 4 to 7, the temperature is decreasing? Yes, it is. Okay, so that is it. If you have any questions, make sure you email me or you message me.